All right, everyone. The point of this video is to look at a few examples of the force of gravity. So I have two problems here. Let's start with the first one. What is the force of gravity on a 50 kilogram box? All right. So there's really not a lot of information in that question. But one strategy that I've mentioned in other videos and I'll mention again is the strategy of using guess. And that's just an acronym for you have to look at what you're given, you have to look at the unknowns, or to try to figure out what is the question asking for. Think about what equation you would use, substitute, and solve. And I really like this strategy, and I'm seeing a lot of students kind of just jump straight into the math, like trying to jump straight to this step, but they are mixing up the numbers. They're not really sure what to do with the numbers, whether it's multiplication or division. So I think going step by step with this will be a really great way to solve any problem. So for this case, we're trying to figure out, it says, what is the force of gravity on a 50 kilogram box? So let's write down what we know. We know that our mass is 50 kilograms. All right. And we know that the question is asking for force. So we have our given and our unknown. And then there's one other piece here, and it wasn't really mentioned, but anything that deals with gravity, especially when we're dealing with gravity on Earth, it has a constant acceleration. No matter what object we're dealing with, the acceleration is always the same. And that wasn't mentioned in the problem because it's kind of a constant that I want you to know, and it's negative 9.8 meters per second squared. All right, that is the acceleration due to gravity. All right, that constant, that's something that we're going to see a lot of in our problems. And it's negative because the acceleration from gravity pulls things down, right? And because it's going down, we consider it a negative. All right, so from here, we have our givens, we have our unknown, and now we need to figure out what equation are we going to use. All right, so we can use our equation that we've been using a lot the past few lessons, which is force is mass times acceleration. All right, from here, once we know what equation to use, we can substitute the numbers into our equation. So force is equal to 50 times negative 9.8. So we plugged in our 50 for the mass, we plugged in negative 9.8 for our acceleration, and with some simple multiplication, we can figure out what is our force. So I'll bring out our calculator here. We would do 50 times negative 9.8, and that's negative 490. So negative 490 newtons. And that's it. And we're done with this problem. All right, let's look at another one. So we have this other one here where it says, what is the force of gravity on a 2,000 kilogram elephant? All right, so as you might guess, we're going to be dealing with something that's a much higher force. But we're going to use our same strategy that we just used here with guess. So let's write out what we know and what's our unknown. So we have force. That's what we're trying to figure out. We know the mass is 2,000 kilograms. And again, acceleration is negative 9.8. And again, it wasn't mentioned in the problem, but that's a constant that we can always assume to be true for dealing with objects on Earth. That is the acceleration from gravity. So we have our givens, we have our unknown, now our equation. What's going to tie all these numbers together? F equals ma. We're going to substitute. So mass is 2,000, acceleration is negative 9.8. So we substituted our numbers in, and then we just solve. So we do 2,000. Ooh, that's too many zeros. 2,000 times, let's see, so everyone can see this, negative 9.8 equals negative 19,600. So the force of gravity on this elephant is negative 19,600 newtons. All right. So those are just a couple examples on how to solve any problem related to gravity. It's F equals ma, just our a is this constant. Sometimes this is called g, so you might see it written as like g equals negative 9.8 meters per second squared. But this specifically means the acceleration from gravity. All right, I hope this was useful. Good luck on your problems.